What we're going to look at in this series of videos is trigonometric graphs, equations and identities. This will focus on the basic trig graphs. So we've got three trig functions. We've got sine, cosine and tangent. What we're going to look at is how the sine, cosine and tan graphs just look at in their most basic form, and like the important points to consider if you're ever asked to identify points or asked to sketch them. So if we're given our xy axis, our sine graph looks like this. Okay, in its most basic sense. Okay, so the points of importance on the sine graph. Along the x-axis, we measure it in degrees. So this point here is 360 degrees. This point here, if you draw accurately, is halfway between 0 and 360, so that will be 180. This maximum point here, if we bring that down, is 90 degrees, and this minimum point here, if we bring that up, 270 degrees. So hopefully we can note that each of the four important points that we're looking at here are the multiples of 90. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. First thing to note is that the sine graph starts at 0. Yeah, I'll just write down what this graph is. This is y equals sine x degrees. So the sine graph starts at 0. It goes up to this maximum value here. To identify what this maximum value is, it's just a property that you need to remember. The maximum value is 1. And certainly due to the cyclical nature of a sine graph, the minimum value obtained at this point here, if we were to go across, is -1. So this is a graph of y equals sine x. Starts at 0, goes up to 1, then down to -1, and then back to 0 at 360 degrees. So this is one revolution of the sine graph. Okay, so the important points to note is that the maximum occurs at 90 degrees, the minimum occurs at 270 degrees, and it crosses the x-axis at 180 degrees and 360 degrees. One thing to note about the sine graph is that although we are just seeing it here in between 0 and 360, this graph will keep on going on and on forever in both directions. But generally, we are interested in the sine graph in between 0 and 360 degrees. Okay, so we've just seen what the sine graph looks like. Let's now examine what the cosine graph looks like. So here's our x and here's our y axis, and let's have a wee go at sketching this. Okay, that's not too bad. Okay, so first thing to note with the cosine graph, so this is y equals cos x degrees, is that it doesn't start at 0, it doesn't start at the origin. Okay, this time we don't start from the origin. How I generally like to remember how this graph looks is I like to think about it like a big U-shaped valley. Okay, if you imagine like a valley and you're looking into it. But the important points to note again are the degrees. So like this is like where our revolution of cos would finish. So this would be 360 degrees. The halfway point, the minimum, is at 180 degrees, and the two cutting points are at 90 degrees, and here 270 degrees. Okay, so similar to before, we're interested in like the multiples of 90. So at 90, it cuts the axis. At 180, we've got a minimum. At 270, it cuts the axis, and at 360 and at 0, we've got a maximum value. And similarly to how the sine graph had a maximum and minimum of 1 and -1. The exact same is true for the cosine graph. Okay, so important points. Maximum at 0 and 360, minimum at 180 degrees, and it cuts the axis at 90 degrees and 270 degrees. I like to remember this as if it were a valley. Okay, the last basic graph that we're going to look at is the tan graph. And I have put in these dashed lines here just to help me draw it, because it is one of the more complex graphs to draw accurately. This graph looks entirely different from sine and cos. It doesn't really share a lot of the same qualities. Once again, the points of importance are 0 degrees, 90 degrees, then we'll go up to 270 degrees, and then let's call this part here 360 degrees. Okay, so to start off with, in between 0 and 90, our graph slopes up as such. Wait, I'll just try and get that in a bit more accurately. Okay, so our graph would be sloping up the way, and it'll be sloping up in line with the 90-degree line that I've just drawn here. But this will keep going on and on and on, up and up and up forever, and it will never actually touch this line. In between 90 degrees and 270 degrees, it looks something like this. Okay, and that's just why I didn't put in the 180, so at this point here would be 180 degrees. So in between 90 and 270, it starts from the bottom, and it would never touch this 90 degrees because this would keep going on and on down forever, and then it curves up the way towards the 270 degrees, but it will never touch that 270 degree line. And finally, between 270 and 360, it would look something like that. Okay, so the important thing to note here is that we do not have a maximum and a minimum value. These curves, they do not touch these lines. This is similarly for here as well. One thing to note from before, when we were comparing the sine and the cos, we would say, like for example, that this was one sine, this was one cos, and those happened within the 360 degrees. And that's kind of what we refer to as the period of a trig graph. Here, a complete revolution of a tan graph happens from here to here. And so the period of a tan graph is the difference between this value and this value. So the period of a tan graph is 180 degrees, whereas in the sine and cosine examples it was 360 degrees. Okay, that's us looked at the basics, how they look, and in the next video we're going to go into a wee bit more information on the amplitude and the period, and maybe look at a few transformations. Thank you very much.